Hi, the goal of this video is to build a custom account that we will use with Account Abstraction on a zkSync local chain. So what I wanted to point out first is if you want to try to find examples of doing similar types of things, come out to docs.zkSync.io and take a look at some of these account abstraction examples. The reason I wanted to point this out first is because there's a couple things that you'll see throughout this video that are little things that you just need to get right in order to get the account abstraction working. I ran into quite a few problems myself when I first came through, and if I had just followed one of these guides, it would have told me the things that I ran into instead of having to run into them myself. I'll point out the couple things that are the little things that you need to get right throughout this video so that you can do the same thing that I'm doing. Awesome. Okay, so the first thing that we're going to do, and they actually tell you to do this in the guide as well, is you could use the zkSync CLI to create a tutorial here, or to create a repository off of a particular template. So in this case, we're going to use the same hardhat solidity. So let me actually just pull this over. But for my tutorial, yeah, you know what? Let's call it custom AA account maybe. Let's say custom AA account, and we're going to use that same template, which is going to create a hardhat repository for us. So let's go ahead and start that up. It's going to ask me a couple things. First, it's going to ask me for a wallet. I'm not going to put one in here because the wallet I'm going to use is one that's going to be pre-populated on my local zkSync error chain. So let me just go ahead and put in my package manager for npm, and this will take just a moment. Okay, great. We're all set up. So there's a couple things that you'll notice that it's saying here. We can go ahead and move into our repository to go ahead and get this started. And it's telling us how to compile and deploy our contracts. So let me just go ahead and move into that. So I'm going to go custom AA account. And then we'll go ahead and open this up in VS Code. Okay, great. So where's my VS Code? It's over here. I'll pull this up. And okay, so now we have our custom AA account. One thing off the gate I noticed that I'm not going to need is my tests folder, because I'm not going to be testing anything. I'm just going to be deploying everything to my local chain. So first thing that I'm thinking to do is in the hardhat config, they've nicely from the template here already set up all these different networks that you could possibly be using. By default, it's going to use zkSync Sepolia. We are not going to be using zkSync Sepolia in this case. We're actually going to be pointed to a node that's going to be running on port 8011. So in that case, I am going to call it the in-memory node for my default network. That way I don't have to pass in a network flag. I can just call the scripts, the deploy scripts and everything like that. And it's always going to use this by default. So one thing that it's going to point out in the guide, and I'll show you why this is important later, is you're going to have to pass in an isSystem flag for the zk Solidity compiler. This is going to be an important flag to pass through. You'll see why in a little bit. We're going to make a system call from inside of our contracts, or inside of our account. And in order to do that, you do need to pass in this flag here. So I'm going to go ahead and pass that in. That is all I think I need to change inside of this hardhat config here. Okay, great. So what I'm going to do next is I'm going to go ahead and run that in-memory node. So you could do this with zk you could use the zk CLI as well. So I think they actually point this out in the guide here as well, right up here. So you could use the zkSync CLI. You could say npx zkSync CLI dev start, and I'll just go ahead and pull this one over. And this is going to go ahead and create a node for me that I can call on the port 8011. Sweet. So there it is running right here. And one of the things that they point out is that there's these rich accounts. So these are accounts that are rich on your local network, right? They actually have a lot of ether to be able to pay the gas. So I'm going to go ahead and get one of those rich accounts. So let me just go ahead and open this URL right here. And what this is going to give me is a bunch of accounts that are going to have ether inside of them. So I'm going to use this first one for the private key for this first one. Let me pull this over into my .env, and there we go. So now we have a wallet that can actually deploy this contract and can actually give some money to our smart account once we get that deployed, our custom smart account. Okay, awesome. So let's just test that everything is working properly. We have this locally running our RPC, we have this locally running node, and we have a private key that has some gas in it. I just want to make sure that everything's working properly. So they have a bunch of really good example contracts in here that we're not going to use any for this video. But what I am going to be using is, let's just use this greeter for now. So that way we can actually just test that we can deploy contracts and interact with them. So I'm also going to be deleting these deploy scripts right here, but I'm going to keep the deploy, the interact, and the utils. And we'll see why in a moment. These are pretty important here. So what I'm going to do first is I'm just going to go ahead and deploy our greeter. So to deploy our greeter, what I'll do is I will come in here and I'll run npx hardhat, deploy zkSync. So this is going to be my command that I can use that's been configured from the zkSync hardhat package that I can use to run scripts with all the zkSync stuff hooked up for me. So the script that I'm going to want to run is going to be deploy.ts, and this is going to go ahead and run this. It's going to deploy the greeter. So it's saying artifact for the greeter is not found. If you see this, the one thing that it's not doing is it's not compiling before we go ahead and run this. So I'm going to want to do npx hardhat compile, and we'll go ahead and do that. And then once we have that working, then we can go ahead and do deploy. Now that's going to go ahead and deploy to my local network. I could take this contract address and I could toss it in here to interact. Now what interact is going to do is it's going to go ahead and read the artifact for greeter that's been compiled and put into my artifacts folder. And then what we're going to do is we're going to read out the ABI and attach this inside of a contract to a wallet. The wallet that I put the private key in there from the .env that has some gas money. We're going to call greet to see the default response. What should the default response be? It should be whatever we passed in the constructor. So it says hi there. So hi there is going to be that default response that's going to come through. And then it's going to go ahead and change that to say hello people. And then we should see that that is indeed the new message at the end of this. So let's go ahead and try that. So I'm going to do the same thing. I'm going to say npx hardhat. But instead of deploy, I'm going to say interact. And so this should do that. It should say hi there. That's going out to that contract. And then it's changing it to hello people. Now, if we wanted to try this one more time, maybe we'll put a bunch of exclamation marks. This time it should say hello people and then put more exclamation marks there, right? Sweet. Okay, cool. So that's working properly. So next thing that we want to do is we want to actually start building our custom account. So in the last video on the paymasters, I talked about this idea that we are going to use a paymaster with an EOA. Now, something that's like a slight technicality on that is it's not technically an EOA on zkSync. It's actually what's called a default account that behaves like an EOA. So you can actually find this. It's a system contract. We talked about system contracts a little bit in the last video, but it's a system contract that can be upgraded on Ethereum L1. So this is what that system contract looks like. Here's the default account. You're going to notice that inside here, and I'm going to pull this over right now, you're going to notice most of the functionality in here is commented to say this is going to behave just like an EOA does, right? That's the key thing here. This default account is encoded. The behavior is set up just so that it could act like an EOA. Awesome. So I'm going to go ahead and pull this over. And we're going to change it ever so slightly so we can have our custom account. And then, of course, you can change it however you'd like after that. Cool. So let me go ahead and let's start making some changes here. Okay. So the first thing that I know I'm going to need to do here is that these interfaces are not inside of my contracts, right? So these interfaces are actually coming from zkSync contracts. And I can find them inside of node modules. They're going to be in the Matter Labs folder here. So I can do this right here, Matter Labs, and then it's going to be zkSync contracts. And then it's going to be contracts on the L2. Specifically, it's going to be system contracts that we're going to care about here. So I believe inside of the system contracts, if we go this far, L2 system contracts, this is where we're going to see everything that we care about. So the interfaces is going to have the I account. It's going to have all these other things here that we are going to be trying to access. So this is where I pulled over the default account from. So I'm just going to need this prefix here on everything. So let's do this, and I'm just going to copy that over, and I'm going to replace the dots here with this prefix so that we get all these imports correct. And if it's working, I expect that I should be able to jump into these things like the bootloader formal address. Looks like it's working, right? We're able to go over there and see what that address is. Awesome. Okay, so that is getting all of those correct. Now I want to change this from default account to my account. I'm going to change this ever so slightly. Okay, so let's call this my account. I'm going to try to simplify this a little bit and add a little bit of custom functionality just so we can prove to ourselves that we were able to change the account around and see some little bit of custom functionality. But you can imagine extending the accounts out as far as whatever you need to do, whatever sort of functionality you want to add to these. So you're going to see, again, that a lot of the comments, it's going to say, these things are going to work just the way an EOA does. So some of the modifiers that we're going to see here, like the ignore bootloader, this is behavior that we would expect from an EOA where if it doesn't come from a bootloader, then we should return just empty data here. So that's what it's saying for all non-bootloader callers, halt the execution with empty return data. So what I'm going to do here is I'm just going to take out a lot of these comments so I remember which parts we had worked on. So for this ignore bootloader, I'm actually going to change this a little bit. I'm just going to make this super simple and say, let's require that the bootloader calls this function, whatever it is. So all the functions that had ignore bootloader before and had that behavior, I'm just going to say require bootloader. So fail if it's not the bootloader. So we could take a look at which ones actually require that they are called by the bootloader here. Okay, great. So, and again, the bootloader, we can think of kind of like the entry point in EIP 4337 account abstraction. So this is going to take a whole bunch of transactions and put them on chain. It's going to facilitate the account abstraction protocol. Okay, great. So we have this require bootloader. The next thing that we want to get rid of here is this modifier, this ignore and delegate call. So what we're going to be doing here is just taking that out. Then we are going to go ahead and for this validate transaction, this is where things are going to start to get interesting. So one thing that we do need to do for validating the transaction, for the sake of this video, I'm just going to get rid of that because I do want to just simplify things here. I'm just going to make it so any transaction is valid. And so that way we don't even need to get the signer correct. In this case, we just want to be able to send a transaction through. We just want to be able to get an account abstraction transaction through this particular account here. So that means that the signature is actually not going to matter. We're not going to validate it, but we are going to have to increment the nonce here. That is something that's important to do. If you don't increment the nonce, then this isn't seen as a successful transaction and it will actually fail. So let's go ahead and just make sure that that is going to work. So in this validate transaction here, I'm just going to keep taking out the comments, the things that we're not using. You can see what it's doing is it's returning this magic value. So again, this is a magic value that basically says this was successful. This is something that's expected to come back so that if it doesn't come back, it's assumed that this is going to fail. So this magic is going to come from this validate transaction function. So inside of here, you can see it's doing a few things. It's calling out to this nonce contract. So here's the nonce system contract, and it needs to be sent through with this is system flag. This, you saw the compiler flag that we passed in before, is that is system flag. So we just need to make sure that that's in there. If you don't pass the is system flag, this is actually going to yell at you and tell you that you can't do a system contracts call to a particular address. It's actually going to show up with an uglier error than that, which may not be obvious why it's failing. So you just want to make sure that if you're going to be doing system calls in here, you want to set that is system flag. So we're going to go ahead and set that. So there's our system contracts caller. We're going to make that out to the nonce. Holder system contract. So this is another system contract that handles all of the nonces for our accounts. So in this case, we just want to make sure that we're going to increment the nonce every time. So that way we come with a unique nonce each time that we go ahead and run this. Okay, great. So that is going to do that. And then this transaction hash right here is going to be used to check whether or not this is a valid signature. And the is valid signature, if we come down here, what it's essentially doing is it's going to be using elliptic curve digital signature recovery to check whether or not this is a valid signature for this account. Now, this is where you could start to get into more interesting things. And if you take a look at the example for the multisig, you could see more other ways that you could validate a transaction, right? If you want to have multiple signatures, if you want to have different types of signatures, that sort of thing, you could do that here. In our case, I am not going to be checking the validity of the signature. I'm just going to take this out, again, to keep things super, super simple. So I'm going to take that out here, and we're going to get rid of this is valid signature. Great. And we're just going to send back that validation success magic, in which case we don't need any of this. So this right here, this total required balance, is going to check to see that you have enough balance to be able to send it over. This might be a good check to keep in there because we want to. So this is going to fail anyway, right? This is something I should point out, is if you try to send a transaction from a smart account and there's not enough balance inside of the smart account to pay for it, this is going to fail anyway, but it's going to fail during execution as opposed to validation here. So we want to make sure that we get a good error back in that case. So that's what this is doing here. Yeah, so maybe we'll keep that in there. But I'm not going to be using this transaction hash. This was being used to validate the signature. So what I'm going to do is I'm just going to be taking that out. And then we could take this over here and we could bring that up into our validate transaction function. So that way we don't have this call to a inner function here, and we could just keep that one function. You know what? We're going to have enough balance in there, so I'm just going to take this out as well. So that way we're just doing two things, right? We're just incrementing the nonce, and then we're just passing back this success magic to say this is a valid transaction, right? Keep things super, super simple. Now I got rid of these two modifiers right here. So what I'm going to want to do is I'm going to want to put in that require bootloader. So that way only the bootloader can call this validate transaction. So the next thing that we're going to want to take a look at is this execute transaction. And in this execute transaction, I'm going to do something similar here where I am just going to get rid of the modifiers. And I'm going to say require bootloader. Again, this is something that we expect the bootloader to call here. We'll take a look at a function right here that is one that wouldn't be called by a bootloader. And you can see in the comments, we'll kind of talk about this, but this method right here is actually a method that you could implement if you wanted to make it so that you do some sort of custom functionality when users are trying to interact with their L2 account from an L1 contract. So this is sort of like an escape hatch, if you want to think about it like that. If you can't, for whatever reason, send a transaction through an operator to the bootloader, then you can actually go to this function here. So when they say from outside, they mean from outside the L2. So it's important to implement this function if you need any sort of custom functionality when you're doing that like sort of recovery process. So I'm going to go ahead and get rid of this here and just not implement this again because we want to keep things pretty simple. And then for the execute transaction, I'm going to bring this down because this has the execute that it's calling right here. So this execute, it's calling into this one. And you can see for this one, it's doing a whole bunch of stuff that it's going to check whether this is a system call, and then it's going to do something different if it's a system call. And it's also going to be using this efficient call here to do a more efficient call, taking advantage of some of the differences in the zkSync EVM system. If we want to make this super simple for our case, and we do, what I'm going to do is I'm going to get rid of a lot of this just to try to keep this, again, really, really simple. So we have this to address right here, right? What this is really trying to do, and I just want to sort of break this down, is it's just trying to make a call to some address somewhere, right? So here's the to address, and then what it's trying to do is it's trying to make a call, and in this call, it's going to be sending some call data, right? And we can take that out of the transaction. So this is the actual like meta of the transaction being passed through to us. And we could take this transaction, we could pass the data to this address. Now we also want to handle if it's going to take some value. So we're going to put the value in here, and we need to say value like that and pass that through. And then we'll check whether or not this is successful, right? So this isn't the recommended way of doing it. You know, you want to do that efficient call stuff, and you want to be able to pass through the system flag if you need to pass that through. But in this case, this is all I care about to be able to send through, because I'm just going to be trying to send to some address, some call data, some value, that sort of thing. That's all we're going to want to do for our example. So I'm just going to even just pull this up into our main execute function, so that way we can get rid of some of these functions here and simplify this even further. Okay, great. So we have our validate and we have our execute done. I think that's pretty much it for our contract. There's some other things in here. So there's this pay for a transaction. This is going to be important. This is going to actually pay back the bootloader for the transaction. So this is going to be called by the bootloader, as the bootloader is doing this account abstraction thing where first it does the validate, then it does the execute, and then it's going to make sure that it gets paid back. Right, so this is another function that is going to be called by the bootloader. So we are going to say require bootloader here. That's the only thing I'm going to change for that one. Great, so we can get rid of that, just knowing that we went ahead and did this one here. Great, and then there's prepare for paymaster, and for this one it's going to be the same thing. So you can see from the comments here, this is where the user should prepare for the transaction to be paid for the paymaster. So if you need to do anything in that instance, you can go ahead and do that in here. So the only thing I'm going to change again is the modifiers here, which I'm going to say require bootloader. Okay, awesome. And then the fallback is doing this ignore and delegate call. We can get rid of that behavior, that's fine. And we have a receive and we have a fallback. We're not trying to, in this case, I'm not trying to mimic the behavior of an EOA. Maybe that would be fine to do, but I'm not super worried about that. So I'm gonna get rid of that modifier, which would just ignore this in the case of being called through a delegate call. Okay, awesome. So this is going to be my account here. This is my custom account. It's much, much simpler, right? We really only care about the validate and the execute, and the validate is just going to return that magic, and it's going to increment the nonce, passing through to the nonce system contract there. And then we have this execute function, which is just going to make a call out to an address somewhere. One other thing I might want to do with my account is just add some custom functionality in here to like sort of give us something that we can latch onto, like something that we've changed that we could test to make sure that this is working the way we expect it to. So what I'm going to do is I'm going to create like a uint public count. I'm just going to set the initial count to 15. Just some random value, just so that we know that this is working properly, right? And then what we're going to do is every time that an execution happens, I'm just going to go ahead and increment that count. That way we could test, okay, is some state changing on our account after this is going through? We'll see the valid transaction go through, but then we might want to just go ahead and test that count. So now what we could do is we can come over here to deploy, and we could change this a bit. So we're going to say my account. We're not going to pass through any constructor arguments because we don't have a constructor. And this will be all we have to do to go ahead and deploy that account. Now, well, there is one more thing. So when you create contracts in zkSync, you actually interact with a system contract called the contract deployer. And that contract deployer is going to have a few different types of contract deployments that you can do. It actually separates out, so there's create and create to, but it also separates out contracts from accounts. Accounts are going to have different properties, so we're going to actually have a different way of deploying an account versus a contract, and we just want to make sure that that is actually going to work here. So these utils right here, set up from the hardhat solidity template, are set up to deploy contracts, not accounts. So if we actually take a look at this right here, it's coming into this utils file, and in this utils file, it's setting it up so that we can do everything that we need to deploy this contract. It's going to tell us the estimated deployment cost, it's going to go grab the wallet, it's going to load the artifact, it's going to do all that stuff. You saw it working with the greeter. That's what we were using in the deploy script to go ahead and deploy the greeter. In this case, what I'm going to do is this deployer right here is actually going to take a third argument where you can actually specify the type of create that you want to do. So you could do a create, you could do a create to, you could do a create to account or a create account. In this case, I'm just going to do a create account. I believe create to account would work fine here as well. So maybe we could test that out, but let's just do create account. And that's all I'm going to change here. So, I do need to be mindful of the fact that if I were going to do this, maybe the better way to do it would be to pass in some sort of another argument to say this create account, something like that. But you know what, like in this case, I'm only going to be deploying contracts, for example. But if you wanted to make sure that you weren't going to break anything with your utils, these utils are only being used by us within these deploy scripts. But if you want to be able to deploy regular contracts and you want to be able to deploy accounts, you might pass in something additional here to be able to differentiate the two. I'm just going to go ahead and pass that in here because I'm going to just be deploying accounts. Okay, great. So now this is going to deploy my account inside of the utils. And then we'll want to interact with our account just to make sure that that is working properly, that there's a count of 15 there. So once we have that contract address, what we'll do is we'll load up my account. And in my account, instead of calling greet, I'm going to call count. And we're going to say current count is whatever the response is there. And hopefully it'll be 15. And we don't need anything else from there. We are going to need that contract address. Once we deploy this, we'll be able to get that. So the first thing I'm going to need to do is going to need to recompile. Hopefully the compilation works. No, it doesn't. It says 0.8.20. So what are we on right now? I got to go down in my hardhat config to see what the current version is. 8.17. So let's go ahead and just do that. 8.17. So now we'll go ahead and compile and see if that works. Sweet. So looks like it worked. It compiled. So now what we can do is we can go ahead and deploy that. So let me just clear this out. We'll do npx hardhat deploy zkSync, and we're going to do deploy.ts. And hopefully this will deploy our account as an account using that create account. So there it is, sending it out. Awesome. Looks like my contract is deployed. So what I'm going to do is I'm going to try to interact with this just to prove to ourselves that indeed there is a count of 15 out there, right? All right, so let's go ahead and interact.ts. Okay, 15. So if we want to get this count up to 16, we really only have one way of doing this. There's no cheating on this, right? We have to actually go out and do the account abstraction protocol, because the only place that we've actually increased that count is inside here of this execute transaction. And this execute transaction can only be called through the bootloader, and the bootloader is going to do the validate, it's going to do the execute, it's going to make sure that it gets paid back. So if we are going to actually be able to increase this count from 15 to 16, we need to make sure that we do everything properly here, right? So that's our goal here now, increase that count to 16. And if we do that, then we know everything has worked. Okay, so that's a little bit tougher than it might seem. So this is going to be the next part, is we need to do the abstraction part, the calling the account abstraction. One thing that I do know I need to do first before we do that is we're going to have to pay back the bootloader. So I'm just going to make sure that we transfer in some money to that smart account. So I'm going to copy most of this over here. Here's the smart account that we deployed. And the one thing that we're going to want to do here is we're going to want to grab the wallet. So let's get our wallet. Again, this is a rich account. It has a whole lot of ether in it. I don't know how many ether it is. It's like 10,000 or something like that. What I'm going to want to do with this wallet is I'm just going to want to go ahead and say wallet.send transaction. Let's get back the response here, and we'll log it out. But with this transaction, what I want to do is I just want to give some money to our smart account. So in this case, as opposed to the previous video, we're going to be paying for our gas fees. You could combine these two videos with the paymaster and the custom account so that you could have a custom account that is being sponsored by the paymaster, right? But in this case, if we don't have a paymaster right away, we're just going to use a smart account that is going to pay for its own gas. So in that case, what we need to do is we need to send some funds to our contract address from our rich account. So we're going to go ahead and say the value that we're going to pass through is going to be, parse ether, and we're going to pass in 1 ether. Because we have plenty. I don't know, it's like 10,000 or something like that. And we'll make sure that we get a successful response here, and then we know our contract has some ether in it. Okay, great. So let's go ahead and do a transfer there and see that indeed looks like the value went through and it's being passed through to that account, 1055. Okay, great. So that is working properly. So the next part that we need to do is the actual abstract piece, right? The account abstraction, where we're trying to send a transaction that's going through the account abstraction protocol. Okay, so for this, we want to do the same thing here where we're going to be exporting a default async function. So this is what we're going to do is we're going to just pass this in here. Now, there's a few things that I know I need to do. So first off, I know I need to import hardhat. So let's just go ahead and do the same thing here to get HRE from hardhat. Okay, so what are we going to need to do? So what we're going to need to do is we're going to need to use EIP 712, which is a typed, it is a way to do typed data, being able to pass through some additional data to the protocol, right? And the reason we need to pass through additional data in this case, so EIP 712, so let's do, there's a serialized EIP 712. And in this method, we're pulling it out from zkSync, so it's going to know the additional data that we can pass on 712. 712, what it is it's a standard for typed data, for being able to pass in additional type data. So the additional type data that we're going to have to pass in here is going to be something called custom data. And you can take a look at this. The zkSync types is set up here so that we can actually see what kind of custom data we can pass through, right? In the previous video, we did paymaster params, right? But in this case, we're going to want to pass through a custom signature that is not the EOA. It's going to be our additional account that we are trying to send this transaction through, right? So this, I do know I need to make a 712 transaction. And so I'm going to pass in some custom data. It's going to be a custom signature. Now, again, I'm not going to be validating the signature in this case. I wanted to keep things super, super simple so we don't get caught up in the, signing a transaction, sending it through and getting all that right. I just want to make it really, really simple. So I made the custom signature. It's not even validating the signature. So I'm just going to make sure I send something through. I do believe that the bootloader is going to get upset if we don't send any signature through, if we just do an empty signature. So I'm just going to send something through, but this isn't getting validated in our account, right? We removed that logic to actually validate the signature. So any signature in this case is actually going to work, right? Which means that our account is actually open for anyone to interact with, right? But it's on my local node, so what does it matter? But yeah, that means that we have an account that anyone in the world can use, which is super interesting. We're just going to pass this signature through and it doesn't need to be validated. So I want to do a couple things here for this serialized EIP 712. What's going to actually happen is this is going to return a serialized transaction. Now I need to put in more in here, right? So this serialized EIP 712, it's going to take all the other, transaction properties like a nonce. And if this is the first account that this is the first transaction that we're going to be sending through here, then the nonce is going to be 0. And then this is going to be from, so we're going to actually specify who this is from, right? Because we're sending a custom signature here where using an account. In that case, the account that we're going to be using is this smart account that we deployed, our custom account. So here's our smart account. So this is actually going to be from the contract address, right? So we're going to say this is coming from the contract address. And here's the nonce. Now there's a whole bunch of other stuff that we do need to populate here for this transaction. Things like the gas limit, things like how much gas, we're going to be doing per unit of gas, right? All of that sort of stuff that we want to be able to pass in here. And what's the chain ID, stuff like that. There is some nice stuff in ethers that's going to help us populate the transaction. So what I'm going to do here is I'm going to cheat a little bit and I'm going to populate a transaction to fill it into my serialized transaction. That way we don't have to go and get the gas limit and everything ourselves. So what I'm going to do is I'm going to use something called a void signer. So a void signer is going to be a signer that actually can't sign anything, but we're going to be using it to be able to populate a transaction just so we can use that transaction object to sort of be filled in here. I'll show you what I mean. So it's going to be a new void signer, and the void signer is going to take a couple things. So it's going to take an address and then a provider. So for the address, let's just do, so we have over here in our in-memory node, all those rich accounts. Let's just do a different rich account over here. So we're going to do, here's the account. So this is the address acting as the void signer, right? We're like pretending we can actually sign with this, but we can't actually do a sign. So that's going to be the address that we're acting like we have the ability to interact with here. And then we're going to go ahead and pass through a provider as well. For the provider, we actually have access to this through HRE. So HRE.zkSync ethers, and then there should be like a provider L2. There it is. So we're going to pass this provider here into our void signer. And that's going to give us our signer. This doesn't need to be inside of the async function, so we'll take that out as well. And with this void signer, what we're going to do is we're going to go ahead and populate a transaction. This is actually going to make asynchronous calls to figure out things like the gas limit. You know, it's going to figure out how much we need to pay per unit of gas. So it's going to populate all of those parameters. So I'm going to go ahead and say transaction is going to be equal to await signer.populate transaction. There it is right here, right? And for this populate transaction, the only thing that we need to make sure that we pass in here is going to be like a to address. We're going to be sending, you know, if we're going to send some value, we're going to send some data, and we're going to send it to a particular address. We want to populate all of that in here so it can properly estimate all of the gas. And then we're going to actually turn it into a serialized EIP 712 transaction. So what I'm going to do here is I'm just going to pass in for the address. We're going to pass in this address, and then this transaction, we're just going to spread it out over this EIP 712. Now, again, this is a bit of a cheat here. I'm just trying to populate this transaction so that we can get things like the gas limit and the, you know, units per gas and the chain ID, all that sort of stuff that we need to get in there. So this will give us everything that we need in order to run this serialized transaction. So the last thing that we need to do here is just we're going to send through this serialized transaction to our provider. So here's our provider right here. We're going to say provider.broadcast transaction, and we're going to send through this serialized transaction just like that. So that's going to go ahead and send it through. This is going to be a promise, so we're going to await that, and then we're going to go ahead and log the response. Now, if this all works properly, what we're basically trying to do is we're just trying to send this one transaction, right? This one transaction from our custom account with a custom signature that's not actually being validated. It's just going to go through and execute whatever the data is that we're trying to send through. In this case, we're sending no data, we're sending no value. But if we wanted to, right, we could send some data in here. We could also do like 0x1337. And maybe we could send some value, right? We do have some ether inside of there, so maybe we could send like, I don't know, parse ether. Let's do 0.001, maybe something like that. Cool. So then we can actually send some value through. We have one ether inside of our account. We'll send some data. All of that's going on in here. So that's actually going to make its way over here. The reason I populate that over here is that so we can get that gas limit correct, right? So that it can actually do the gas estimation correctly. And then, yeah, we're going to be sending from this contract address all of that. And it's going to be doing the account abstraction here. Awesome. So let's go ahead and see if that works. I'm going to clear this out, and we'll say scripts.account. And let's just make sure, yep, that looks like the right contract address. So let's go ahead and do, not account, abstract. All right, so it's saying account validation error. Did I actually transfer? Did I just, yeah, I did, okay. So the value is being sent over. But it's giving me an error saying account validation error. That's interesting. Why is there an account validation error? Okay, so it's definitely giving me an account validation error here, which if we go back to our account, one thing that we'll see here is this require bootloader. This is probably the culprit here. So it looks like what I did by accident is I did not flip around the assertion here. So it was doing some behavior if the message sender is not the bootloader. But what I really wanted to do here is when I go to change it to require is I want to require that the message sender is the bootloader, right? And I didn't flip that around when I did this. So this is really what I wanted. This is a good lesson to make sure that you pass in like a error message here, because I think that would have helped us catch this. So I think I could say only the bootloader. That would have helped a lot had I put that in there. So let's just go ahead and redeploy this contract. We're going to redeploy an account here. So what I'm going to do is I'm just going to clear this out, and I'm going to say npx hardhat deploy, and we'll do deploy there, and we'll get ourselves a new account. Oh, you know what I forgot? I forgot to compile. So let's just make sure we compile. Otherwise, we will have not made that change, and I'll come up with the same validation error once again. So let's do that. We'll compile. Now clear again, and we're just going to go ahead and do deploy. And here's our new account once again. All right, sweet. And let's just do a couple things. Let's make sure that this count is set to 15 so that we know that it worked properly. Double check our work a little bit. If we interact, there's our count, it's 15, sweet. And now what we want to do is we want to transfer to this account 1 Ether, right? So that it could pay for costs. And then we'll go ahead and pass that through. Looks like it's being sent through. So there's the value, and then it's being sent through to this account. So the last thing that we need to do is actually come in here to our abstract function. And this time, hopefully, we'll actually be sending that through from our contract address. So let's clear this out. Let's do abstract. Great. Looks like it passed through. So did we pass? We passed some data and we passed some value. Is that in there? There's the value. There's the data. Looks like it's in there. It's sending from this new smart contract address right here, this one right here, to this address, which is that rich account, that second rich account. Okay, awesome. Looks like we're sending some value through. If we want to test that this is actually working properly, right, maybe we could just make sure that non-zero is not going to work again. If we ran this again, right, what would we expect to happen? If we ran this again, the nonce is not valid this time because we already used non-zero, so hopefully that would fail. Let's go ahead and see that that fails. Okay, it says reusing the same nonce twice. Actually, that's a great error message, right? That's exactly what we did. We tried to use the same nonce twice. So if we incremented this to 1, and just for the sake of it, maybe we'll just do parse ether 256, right? And we'll pass that through just to see something else being passed through here. And there's our value, 256, with a bunch of zeros after it. We're sending the data through, and this looks like a valid transaction. So awesome. We did it. So that was the goal of this particular video, is we made a custom account, right? We made this account here by using the default account. The default account, again, is going to be the logic that's used at every account, every address on zkSync that does not have code at that address. So it behaves like an EOA, and it is actually what is called when a contract is an EOA, right? When it doesn't have any contract code there, that is actually what's called is that system contract, the default account. So we took that default account and we customized it. So we added our own account, or we added our own count here, and we added some of our own logic. We took away some of the validation, and then we deployed that using that special account code to be able to do a create account. And then we were able to use that account to be able to send a transaction through using a custom signature in this case, which is just a signature that was not validated, right? But if you wanted to do some sort of other type of elliptic curve or some other type of public key cryptography there, you could certainly do that in there as well. So whatever you want to sort of make into your account, you could do it here with this sort of setup. Great. So that's everything on custom accounts. Hopefully you enjoyed that, and we'll see you in the next video.